Hi. Today I'm going to cover movement. This is a basic movement script, but my main purpose is to try and explain how it works. So what we're going to do, the only thing I have is an object player that has the sprite player attached to it. I have a room with the object player inside of it. Then in each of these events that I have inside of the player, create, step, and draw GUI. I just have event inherited. Let's get started. So we're going to create a class object inside player classes, class movement. We're going to add a create event. Inside the create event, we're going to create a speed variable. Speed is going to be equal to display get height divided by 30 times seconds. And we're going to make another variable called seconds above that equals, let's say 5 for now, and set seconds to equal, or seconds equals time to go from top to bot to top. So what's going to happen is we're going to create a script get movement. Inside this script, we're just going to have the basic movement, which is hspeed equals keyboard check ord D minus keyboard check ord A, vspeed keyboard check ord S minus keyboard check ord W, x plus equals hspeed times speed, y equals vspeed times speed. We're also going to go up and we're going to create a variable called p, and we're going to set p equals keyboard check ord P. Then we're going to create a step event, and we're going to script execute script get movement. So every time the game steps, it's going to run the script get movement and react accordingly. So the first thing I'm going to want to do now is I'm going to want to go into my draw and create a draw GUI class or event. And then inside of it, we're going to draw text equals, or no, draw text parentheses, and we're just going to write 100 by 100, which will show about here on the screen. And we're going to make the text p, the variable p, which, if you remember, is this. It's not this, it's this. P, keyboard check ord P. Okay. So when we press P, it's going to show up on the GUI about here. Oh, you know what I didn't do? Didn't inherit from the parent. At this point, that seems to be my pattern, not inheriting, and it's become a routine, and I need to fix that. Okay, so as you can see, it just says 0 right here. So P is not being pressed. We're pressing W, S, D, and A, Y, M, but P is not being pressed. When I press P, so right now the value of P is 0. When I press P, it's 1. So now we know that what those checks do, the keyboard press ord checks do, is return 1 if it's true. So in our script, what we're really saying is hspeed equals 0 or 1 minus 0 or 1. Now the way the grid is set up, it's 0, 0, so 0x and 0y. So 0y is up here, and on mine it's 900 pixels, so the most would be down here. But the grid changes depending on your display size or room size, depending on what you're basing it off of, how you're doing that. But what you need to know is that y is 0 at top and the most at the bottom, x is 0 on the left, and most on the right. So what that means is, if keyboard D is being pressed, which is our right movement, it'll say +1. Then if A is not being pressed, so 1 minus 0, so it'd add to x, so +1 to x goes this way. Now if D is not being pressed, so it's 0, then minus A, so -1 because A is being pressed, then it's going to go this way. It's going to negate 1 from x, because x plus equals, well, it's not negating 1, it's negating 1 speed per 1 step speed. So h speed, which is that, the 1 or -1 or 0, and same with v speed, is -1, 1 or 0, times speed. And our speed is in here, which is display get height divided by 30 times seconds. Now before I set this next piece, I'm going to just quickly explain why this is. So display get height is going to give you a value. So I'm just going to give you my height of mine, of one of my screens, which is 768. So we have 768, and then it divides it by 30 times 5, which equals 150. So then each piece is going to get a number. So let's get a calculator, because it's going to be a decimal. 768 divided by 150 equals 5.12. 5.12. These are the pixels. These are steps. So 768 screen height divided by 150 steps equals 5.12 pixels per step. And so if you were to times 5.12 times 150 steps, you're going to get 168. Now let's say the screen height was 900. And I'm just going to write just the first 2 letters just to keep it correct. And it's slipping my mind what that's called, and somebody will call me out on it, but you know what it means. It means screen height, and 150 steps. And what we're going to want to do is take our calculator, and it does this automatically, but just for this to show you, 6. So it should move 6 pixels per step. So 6 times 150 is 900. So, and what this does is, so on the 768, it moves 5.12 pixels. But that's not really important. What's important is that it's moving 1/150th of the screen per step. And it doesn't, so it doesn't matter what the screen height is, it's always going to move 1/150th per step. So if it's 768, that 1/150th is 5.12. If it's 900, that 1/150th is 6. What this means is no matter what screen resolution you have, it's going to move at the same speed. But we have it set off of height, display get height. So the next thing we're going to want to do is create display or no, window set size, and we're just going to do display get width, display get height. So what we're doing is we're making sure that when the window is loaded, it's equal to whatever the window size, the display size is. Then the other thing we're going to want to do is set window set position, and we're just going to set it equal to 0, 0. Now I'm going to cross it, and I'm actually going to change this just a little bit because this does load on my other screen and I need to be able to move it. And at 0, 0, it just shows what's inside the box. There's no padding, so you don't see the piece to drag it over, which I need to do. So I'm just going to set both of those to 10. And actually, I don't need to set the width to 10. I just need to set the height to 10. The height position to 10. And what this will do is it'll make it so it's 1, 2, 3, 4, 5, 10, somewhere around like that. It'll just be a little bit of a box so I can drag it over. But ideally it should be at 0 to have inside this, but because I'm making a tutorial, I need to drag it. So those two, this one sets a size equal to the display size, the window size, and the window set position sets the window position to this. Otherwise, when it first creates, it'd create like this. Then when it goes to resize, it would do it like this. Except it wouldn't go up like that. It would just come down and to the right. But by resetting the window position to 0, 10, it's going to be right about like this. It's going to load like that. And then at the top, it's going to have this piece that's right here, that where it says event class movement. Oh my goodness. I hate Windows 8. Like, it's great. I'm not a fan. I don't need it to do all this stuff on a PC. On a phone it'd be alright, but... Okay, so the first thing we're going to want to do now is run it. And I keep saying the first thing, like we haven't done a bunch already. And setting height to 10 wasn't enough. I'm going to set it to 100. And alternatively, I might just take it out if that's not working to make it so I can bring it over. It is. There we go. Just 10 wasn't enough. The only other thing is, because it's on my main screen, the reason that it's not all the way on this one to the left or right is because it's set up for my my other screen, because that's my main. So what should happen is it should take 10 seconds to get from top to bottom. Now it goes a little bit off, so I'm going to put it right about there, and you can see it right here. And I think it does go just a tiny bit more than that right there. So yep, we're right at the bottom. Should take 5 seconds to get to the top. Let's see. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5. And we hit 5 right as we went into here. And if we would have been able to keep counting, it would have went up, up, and hit this. And because it's just the way we set the window too, because I had to minus 100, I lost a little bit because I set the window position down 100. So instead of going to here, it shows me this. So if this was up a little bit, it would be 5 seconds as it gets to the top. 1, 2, 3, 4, 5. And it hits 5 right as it's at that top. So again, H speed, 1 or 0, minus 1 or 0, and it's based off the way the grid goes. So that's how you remember which one to put first. If it's positive, if you want to move, if it's to the right, it's D, because that's plus 1. So that needs to always go first, and then minus A, which is to the left. And I'm repeating myself, but I want to make sure that that sticks. I'm going to remove this for now because it doesn't matter for me. And it's actually a pain because when I click play I have to drag it and all that, whatever. But what I wanted to stress was 30 times seconds. So if I change this to, let's say, 7, what we should see when we load it is that it should now take 7 seconds. So I'm going to just push this right here. So let's do it. 1, 2, 3, 4, 5, 6, 7. And it hits 7 as it hits there. So that's just something that I like to do to break it down. You put the seconds and then just times 30, and that's what you divide by. So it's only moving, because this equals 150, or well, when it's times 7, it equals 210. So speed equals 1 210 chunk per step. So no matter what display size is, it's going to move that amount, just one chunk per step, as long as you have seconds to 7. And it'll work no matter what size the display is. The only thing you have to make sure is that you set the size to display get width. Otherwise, you would be doing it based off room width and room height. I think that covers everything I wanted to go over, except for maybe this formula. So when we have x, we're adding h speed, which is 0 or 1 times speed. So times that chunk, times 1 210th if it's times 7, times 1 150th if it's times 5 seconds. And that's how much it moves each step. And because step is the same on every device, the only thing that's going to change is the view, the visual. So it may look bigger on a bigger screen, but it's still going to take the same amount of time. On a smaller screen, it's still going to take the same amount of time. It's going to move much more slowly, or it's going to look like it is, but it's still going to take the same amount of time as it would on any other screen. Now there is more you have to do to that with the views and drawing to make sure that the sprite also changes its scale, which I do plan to make a video on in the future. And it will cover having a smaller screen and showing what it would look like, the scaling, the Y scale, and adjusting the sprite size based off display type, well, width and height. I hope that explains it well. I know this video kind of ran long, but I really wanted to make a point of explaining what's going on inside of the code. Thanks for watching. Have a good one.